Okay, so Assalamualaikum warahmatullahi wabarakatuh. And good morning everyone. Okay, so rasa macam dengar dia sound okay kot Okay kot. Okay Hopefully everything is okay. Okay, so kita ni kejap. Okay, so let's start then. We have to start with the new chapter, chapter 8. So we are nearly at the end. We got chapter 8, chapter 9 and chapter 10. So there are 3 chapters left. And after we started with chapter 8, there are 2 chapters left. Sikit lagi nak sampai hujung lah, sikit lagi. Okay, so now limits and continuity. Oh, yang ni saya tak edit pun, saya ambil je yang diorang bagi sebab nampak macam cute je. Okay, limits and continuity. So in lecture 1 and lecture 2, we are going to do 8.1, where 8.1 is all about the definition of limit, since you haven't heard of limit before. So we are going to do, or we are going to define what is limit, what are the properties of limit, how to find the limit, and then what does it mean by one-sided limit, and then how to prove the existence of limit, and what happen if we are having something with infinity for the limit, and then if let's say we want to approach infinity for the limit as well. So those are what we are going to learn today and next week on Sunday as well, because today is Wednesday, right? So we are going to learn 8.1 today and then next Sunday. So for the third lecture, we are going to proceed with 8.2, where we are going to find out how to calculate the asymptote, either the vertical or horizontal asymptote. Okay, and then for the fourth lecture, of course, you only did something with limit. So that means in fourth lecture, that will be something to do with continuity. So we are going to discuss the continuity of a point at a certain point. So those will be for lecture 4. So altogether, we are going to spend around 4 hours for this chapter. So that means this week, next week, and the other week. And we are supposed to finish them by that Sunday, lupa kelas hari apa. Okay, Sunday, next 2 week. Okay, so now limits and continuity. The first lecture at the end of the lesson. So this is the learning outcome for today. You should be able to state the limit of a function as x approaches a given value, which is a. So the limit for x approaches a for fx equal to L. Okay, so we are going to find out what is this L value. Oh, by the way we write down the limit, okay, so you need to have your limit first. So write down the limit. I normally use the liter, L yang macam liter tu. But if you want to write down this kind of limit, that is totally okay as well. So limit, and then make sure to have x approaches what? They should be below the limit. So for example, over here, x approaches a, oops, and the function fx. So the function will be on the right hand side. So we should have x approaches a value below the limit. So that is how we are going to write them down. Okay, and then you should be able to apply the basic properties of limit. So we are going to discuss the basic properties of limit. We do have quite a few properties of limit. So we are going to discuss about that properties. And then you should be able to find the limit when the limit at the top and the limit at the bottom is 0. So basically both of them are 0. So we are going to see what will happen when we get 0 over 0. as the limit. So you substitute or you find out the limit for the function at the top, you find out the limit for the function at the bottom, and then suddenly we do come out with 0 over 0. Do you guys realize that 0 over 0 is not defined? We couldn't we didn't know what is the value when we have 0 over 0. So that is the reason why we are having these two method, either factorization or multiplication with conjugate. We want to make sure that we don't have 0 over 0 in our calculation. So that's the reason why we are having these two method. Oh, by the way, if we have 0 over a, this is okay. 0 over a is actually 0, as long as a is not 0, of course. 0 over 1, 0 over 2, 0 over 5, 0 over pi, those are 0. If we have a over 0, then they will become infinity. If we have something over 0, if 0 is at the bottom, then they will become infinity. So 0 over a is 0, a over 0 is infinity, but when we have 0 over 0, we will have a problem. So that's the reason why you should either use factorization or multiplication with conjugate. And then the last one, the linear outcome for today is that we should be able to find the one-sided limit. So why one-sided limit? Okay, so sometimes our function might define starting from 3 up to the right hand side. So that means we don't have any graph on the left hand side of the tree. So we only can approach tree from the right hand side. So that's the reason why we are having something called the one-sided limit. And sometimes one-sided limit can be used when we have a piecewise function. So ada piecewise function. So we got a different function on the left hand side of 3 and right hand side of 3. So different function, one on the left, one on the right hand side. So that's the reason why we have to find the one-sided limit as well. Okay, next. Itu briefing je lah, tak ada apa pun. Okay, so now definition of limit. A function f(x) is said to approach a constant L as a limit x approaches a as below. Okay, so the limit for x approaches a, the way we write this, the way we read this is that the limit for x approaches a for the function f(x). And when we find out the limit, the value is L, where f(x) is the function which assume a corresponding set of values and x is the independent variable. Okay, that's okay. So one thing that you should be noted with the limit is that the key point with limit is that we are not interested in the value for f(x) when x equal to a. Basically, if we are interested with f(x) when x equal to a, then this is simply f of a. So that means if you have a function, this is fa. Oops. Dia tak nak bagi saya bulatkan lah. Macam mana? Tak, dia macam sensitif gila. Okay, this is A. A. Okay. Okay, so as x approaches A, so this is our FA. Okay, so we are not interested with the value for fx when x equal to A. So not exactly at x equal to A, but we are interested in the behavior for fx as x comes much more closer to the value of A. So that means we are not really want to find out what is the value exactly at A, but as it approaches A from both left hand side and right hand side. Kita nak tengok nilai tu berapa. Bukan nilai ngam-ngam kat situ tau, tapi yang hampir dengan dia kat sebelah kiri dengan sebelah kanan dia. Okay, so now these are the properties of limit. Okay, the first properties is that if fx is equal to k, where k is a constant, then the limit for x approaches a. So you're gonna replace fx with a k. Let me change the color. Okay, so this is fx. Okay, fx, you replace them with the k because the function is fx equal to k. So you replace fx with k. So this is the limit for x approaches a for the k. So it basically, if they are a constant, then you simply substitute the constant in. So k. If let's say fx is equal to 8, fx is equal to x. Oh, x pun dah jadi 8 dah. If fx is equal to x, then the limit for x approaches a. Oh, habis dia. Kenapa dia tulis kat sini? Patut kat sini. So the limit for x approaches a for fx. So you simply replace the fx with x. So this is the limit for x approaches a for x. So they will become a. So in other words, it will simply be, you just substitute x with a. Tapi dia bukannya kita nak dapat ngam-ngam nilai dia berapa Ini sekadar menghampiri. Tapi bila lama-lama dia macam kita substitute dah nilai dia. Sebab makin lama makin kecil nombor tu. So dia akan jadi sama macam kita ganti nilai terus sahaja. So sebab tu kalau ikutkan lepas ni semua macam ganti nilai je lah. Suka hati je aku cakap bahasa Melayu. Okay, next. Right, so if fx is equal to x to the power of n, where n is a positive integer, then the limit for x approaches a for fx, so you simply replace fx with x to the power of n, and then find out the limit. So substitute x with a, we are going to get a to the power of n. So that is how we are going to find out the limit. Okay, so this is by using the property 1, 2, 3. We got a lot more to go. Okay, so basically, if k, a, b, and c are real numbers and the limit for x approaches c for fx is equal to a, and the limit for x approaches c for gx is equal to b, then if we have the limit for x approaches a, if let's say you have some constant right over here, if you have some constant for the limit, you can actually take out the constant and then find out the limit for x approaches a for fx. So that is what they mean by the fourth properties over here. If you actually have some constant, you can actually bring them out. So for example, if let's say you have the limit for x approaches 2 for 2x, right? So you can actually bring the 2 out. So you have the limit for x approaches 2 of 2x. Ayah, jap. Dia macam tak respon cepat lah. Respon dia slow. Why is that? I don't know. Tak apalah. Sabar. Bukan semua benda akan laju. Okay, so now if let's say you have some constant, right, for your function, you can actually take them outside of the limit and then find out the limit that having some x inside them. So for example, over here, the limit for x approaches 2 for 2x. So we can actually bring out the 2 outside. So we have 2 limit for x approaches 2 of x. So that is what happened with the fourth one. And then next. Okay, so basically if you have a plus and a minus inside the function, you can actually separate your limit into 2. So you can actually solve the limit for x approaches a for fx first, and then find out the limit for x approaches a for gx, and then combine the value for the limit then. So that is one of the steps to do it. And then 4, 5, 6. Alright, so for the 6, if you have the limit for x approaches a, fx dx, so we actually have some multiplication over here. So you can actually separate the limit as well. So you can actually find out the limit for x approaches a for fx, and then you can multiply them with the limit for x approaches a for gx. So if you have an addition, you can separate the limit. If you have a multiplication, you can also separate the limit. So plus, minus, multiply. So one more, it will be for a division. So basically, if you have a limit and then those are a fraction or a division, then you can actually separate the limit into 2. So we're going to solve the above part first. So solve for the numerator part, and then you find out the limit for your denominator part, and then you can combine them together. But there is one thing that you should note, that b is not equal to 0, because otherwise we are going to get something with infinity. So it's no longer a over b, sebab nanti dia akan jadi infinity kalau b tu kosong. Okay, next. Right, so find the following limit. Okay, so the first one, we have the limit for x approaches 3 of 5, b the limit for x approaches 4 for x, and then c the limit for x approaches 4 for x cubed. Okay, so these are actually the properties, the first, the second, and the third properties. So this is the limit for a constant. Oh, saya lupa saya bagi warna putih tadi. Patut tak nampak pen tu duduk mana. Okay, so find the following limit. So the limit for x approaches 3 for 5. So this is some constant. So you can refer to the first property if we have the limit for x approaches a for a k, right? So k is a constant. Therefore, the value is simply the constant itself because this is some constant. Okay, so now the limit for x approaches 3 of 5. So the value for k is 5. So the limit is simply 5. Okay, B. B is about the second property. So if we have the limit for x approaches A for x, so we simply gonna substitute x with A, of course. So this is simply equal to A. Okay, so what happened over here? So the limit for x approaches 4 for x. So the function here is x. The A is a 4. So the value for the limit of x approaches 4 for x is simply equal to 4. So you simply kinda substitute x with 4. Okay, so now the limit for x approaches 4 for x cubed. Okay, so this is the third properties. Limit for x approaches a for x to the power of n. So this is a to the power of n. So we simply replace the x with a, of course. Therefore, the limit for x approaches 4 for x cubed will become 4 to the power of 3, and then you can actually use your calculator for them. 4 cubed is simply equal to 64. So this is how we are going to use the properties. So this is the first, second, and third property. Okay, so let's move on to the next one. Find the limit below. Okay, so we have the limit for x approaching 2, 5x cubed, the limit for x approaching -1 for x cubed minus with 10, the limit for x approaching 4 for x cubed, x plus 1, the limit for x approaching -5 for x over x squared plus with 10. Okay, so now let us focus on the first one. You can actually use the property of the limit. Okay, so we see some constant over here, so we can actually take out the constant, so 5. And then this is the limit for x approaches 2 for x cubed. So this is by using the fourth properties, if I'm not mistaken. Okay, and then this one, you can actually solve them by using the third property where we have a to the power x to the power of n. So you can actually use the third property over here. So this one will become 5. Okay, so substitute x with 2. So we got 2 to the power of 3. So 5 multiply with 8, which is simply equal to 40. Okay, so now do see my working step. Over here, I still have them in terms of x. Okay, over here, I still have them in terms of x. So this is the limit, right? So I have them in terms of x. But once I want to substitute them with x, then therefore, I no longer write down the limit. So if let's say you already substitute with the value of x, then simply get rid of the limit. Okay, let's see the next one. Okay, so we actually have a minus over here, so you can actually separate them into two. So you can calculate the limit as x approaches -1 for x cubed minus with the limit as x approaches -1 for 10. Okay, so the limit for x approaches -1 for x cubed. So this is basically using the third property where they are actually -1 to the power of 3 because we have a to the power of n using the third property. And then the limit for x approaches -1 for 10. 10 is some constant. So I simply gonna write down the constant. Therefore, this is -1 cube minus with 10. So -1 cube is -1 minus with 10. So the answer for this one is -11. So that is for B. And then C. C, you can actually use the property where we actually have a multiplication. So you can actually separate them into two. Let's see, can I write them down over here? Okay, so this is actually equal to the limit as x approaches 4 for x square multiply with the limit for x approaches 4 for x plus 1. Of course lah, kalau nak pecah lagi pun boleh jugalah. Okay, but never mind. I simply want to find out the value straight away. So this is the limit for 4 square multiply with 4 plus with 1. So 4 square is 16. 16 multiply with 5. So the answer is 80. Okay, so now D. D is the limit as x approaches -5, x over x squared plus 10. So basically, you want to separate them into two because this is a division. Therefore, they are the limit as x approaches -5 of x over the limit as x approaches -5 for x squared plus with 10. And then of course, you're going to use the property. So this is the second property, right? Because we only have x. So you can actually kind of substitute x with -5. Therefore, this is -5 over -5 square plus with 10. So this is -5 over 25 plus 10. So this is 35. So -1 over 7. So always make sure to leave your answer in the simplest form. Always make sure to simplify them. And make sure not to have any set in your denominator because we have learned in chapter 1 how to rationalize our denominator. So avoid having any set in your denominator. That will be very nice. Okay. Oh, by the way, kenapa saya pakai L yang macam liter tu kan? Sebab dia macam lawa masa cikgu saya ajar. So, saya pakai L macam liter tu. Boleh tak bagi alasan itu? Boleh lah kan? Okay. Proceed. Okay. Dia lambat sikit. Okay, so now C. Find the limit using factorization and multiplication of conjugate. Okay, so if the solution for the limit of the rational function, okay, so just now we learn, right, how to find out the limit. If let's say we have a division and then we find out the limit for our numerator and our denominator, and all of a sudden we do end up with 0 over 0, then we get stuck because we didn't know what to write down if we have 0 over 0. Therefore, we are going to simplify them. When you simplify, you have two methods, either factorization or multiplication with conjugate. But of course, when we are talking about multiplication with conjugate, it must have something to do with conjugate of a set. So most likely they will have something to do with a set. If you have a set, then most likely you are going to use multiplication of conjugate. Okay, so what is actually our aim? Either to factorize or multiplication of conjugate. Our aim is to actually cancel out the term that will give us 0 over 0. When we have 0 over 0, there must be a term that will give us 0 at the top and 0 at the bottom. So now our job is to cancel out those two terms so that we do end up with some value at the end. So we no longer having anything with 0 over 0. We will get some value later. Okay, so now factorization method. Okay, so for example, if let's say you want to find the limit for x approaches 3 for x square minus with 9 over x minus 3. Okay, so the first step whenever we see the limit is that we must try to substitute the value in first. Okay, so let's see if we try, right? So this is the limit for x approaches 3 for x square minus 9, and then over with the limit for x approaches 3 for x minus 3. Okay, so if you try to substitute x with 3, you should be able to see you are going to get 0 over 0. So substitute with 3 over here. So 3 square is 9. 9 minus 9 is 0. 3 minus 3, that is also 0. So somehow we do end up with 0 over 0 and we get stuck because we don't know what is 0 over 0 is. Okay, so now I'll teach you one of the method which is factorization. Okay, so how do I know I need to use a factorization? Okay, so normally for me, I do check the power. Okay, so this is a square. This is x to the power of 1. So I'm going to try to factorize the x square so that I can have two linear function. Biasanya kuasa tinggi lah nak tukar kepada kuasa rendah tu. Sometimes if you couldn't see them very clearly, especially when it's involved x cubed or x to the power of 4, then you might want to use a long division in order to factorize them much more clear. So this is x square, right? So you can factorize them easily because you can use the cross method or you can use your calculator. But if let's say we do have something with x cubed or even x to the power of 4, you will have some problem in order to factorize them. So that's the reason why we have to do a long division for them. Once you do your long division, so this is your px, this is your dx, you are going to get your qx, right? Then you can write down px as qx dx. Since they are a factor, then the remainder should be 0. Okay, so this one is when you have either x cubed or x to the power of 4 and you didn't know how to factorize them. Okay, but x square, you can actually factorize them very directly. So this is actually equal to the limit as x approaches 3 for x plus 3 and x minus 3 over x minus 3. Okay, so since we are talking about the limit, x approaches 3, it simply means that we are approaching 3 but not exactly at 3. Therefore, the value is almost 0 but not exactly equal to 0. Why did I say that? That is because we want to cancel out the term. So if you want to cancel out the term, you cannot cancel out if you have 0 over 0. But if they are almost 0, then we can cancel them out. Okay, so you can actually cancel out x minus 3 and x minus 3. So they will become the limit for x approaches 3 for x plus 3. So substitute x with 3. Therefore, they will become 6. So if you want to cancel out this thing, you must have the word limit in front. Sebab limit ni maksudnya menghampiri. So kita boleh cancel lah sebab dia bukan betul-betul kosong. Okay, so now that is for the first one, factorization method. If let's say this is the limit for x approaches 3 and then you have x cubed minus 27 over x minus 3. If you do try to substitute, you will end up with 0 over 0. So you will have some sort of problem over there. So what happened next is that you are going to do the long division for them. Once you do the long division, then you can find out the limit for x approaches 3, x minus 3, and a quadratic function over here over x minus 3. Then you can cancel out the term that will give you 0 over 0. So this is the limit for x approaches 3 for x squared. So this is what I mean by you might need to do a long division if you cannot factorize them completely and easily. Okay, next. Right, so multiplication of conjugate method. Okay, so let's say we have the limit for x approaches 1, square root of x minus 1 over x minus 1. Okay, so again, whenever you see the limit, you should try to substitute the value in first. Okay, so this is the limit. as x approaches 1 for square root of x minus 1 over the limit as x approaches 1 for x minus 1. So substitute x with 1, we are going to get 0 over 0. So if we have 0 over 0, then we will come to this step, either factorization or multiplication with conjugate. So you should check first, either do you want to factorize or multiply with conjugate. Okay, so normally for me, I don't see anything with a square, so I do think that I won't factorize them, but I'll try to multiply with the conjugate. And another one is because I have a set over there, so I know I can easily calculate its conjugate. So that's the reason why I'm going to multiply with the conjugate. It doesn't really matter where it's the set. So either it is in numerator part or denominator part, as long as you have a set, you can actually times with the conjugate. Okay, so now I'm gonna times with the conjugate for them. So multiply with set x plus 1 over set x plus 1. Okay, so expand them very carefully. So this is set x multiply with set x multiply with 1, negative 1 multiply with set x, negative 1 multiply with 1. And of course, for our denominator, you should keep them in those bracket. Basically, if you multiply with its conjugate, then you expand. Otherwise, you leave them as the bracket. That will be much more easier. So this is a tips that I'm going to give you, okay? If you times with your conjugate, then you should expand them. If you didn't multiply with its own conjugate, then just leave them as the bracket. Okay, so for example over here at the top, I can see that I'm multiplying with its own conjugate, therefore I'm going to expand them. So they will become x minus 1. In my denominator, that is not the conjugate of each other, so I'm going to leave them as the bracket. Okay, and then I will have x minus 1 over x minus 1 square root of x plus 1. So cancel out the term, that will give us 0 over 0. So we are left with the limit for x approaches 1, 1 over square root of x plus 1. So substitute x with 1. So we are going to get 1 over 2 as the answer. Okay. Next. Taklah bagi masa lah aku nak salin kan. Okay, next. Actually, you should get the idea first, you know. Okay, so I do see some limit, even though we know this is 0 over 0, but never mind. The first thing, whenever you see the limit, you should try to substitute first and see what happened. Because sometimes, most of the time, when you didn't substitute the limit and you want to straight away do all those things, the factorization or multiplying with the conjugate, sometimes it won't work. And you have a big problem later on sebab you tak ganti, you tak sedar pun dia tak dapat kosong per kosong. Okay, so now substitute first. So the limit for x approaches 1 for x minus 1 over the limit of x approaches 1 for square root of x minus 1. And then when you substitute, you are going to end up with 0 over 0. Oh, this is a problem. Therefore, you should choose either to factorize or multiply with conjugate. Okay, so since I do see something with a set, then I choose to times with the conjugate. Okay, so what is the conjugate? Okay, so we are going to times with set x plus 1 over set x plus 1. And like I told you before, if you are multiplying with its own conjugate, then you expand. Otherwise, you're going to leave them in a bracket. Okay, so for example over here, this one, I'm going to multiply with this one. However, they are not the conjugate of each other, so I'm going to leave them inside some bracket first and see what happens next. But for my denominator, they are actually the conjugate of each other, so I'm going to expand them. Okay, so when I expand my denominator, I should have x minus 1 in my denominator. And then as you can see, we can actually cancel out the x minus 1 and x minus 1 because we have the same thing at the top and at the bottom. So this is the limit for x approaches 1 for square root of x plus 1. Therefore, this is simply equal to 2. What happened if, let's say, you leave them inside the bracket and still you couldn't see anything that can be cancelled out? Then most likely, whatever inside of the bracket can be factorized further. So sometimes dia memang kena macam campur-campur sikit. Dah buat conjugate, oh masih tak boleh cancel, then kena factorize sikit lah. Baru boleh cancel out. But normally, you should be able to cancel out something when you either doing factorize or conjugate. Okay, next. Right, so this is one-sided limit. Okay, so for example, if let's say this is x, so this is 0. Okay, so we notice that as fx is our function, of course, as fx approaches 0, as x approaches 0 from the left, so this is the function from the left-hand side, and fx as x approaches 0 from the right-hand side, they do have a different value. So right, left. So the value for fx is different. From the left-hand side, the value for y is 0. From the right-hand side, the value of y is 1. Therefore, I can say that this is one-sided limit because we can actually calculate the limit from the left-hand side or right-hand side. If you want to write them down, so the limit for x approaches 0. So this is from the right hand side, right? So you should use 0 from the right for fx. The value for the y is 1. So ini yang wording tu lah, tukar kepada formula lah. Okay, so this one left 0. So that means this is the limit as x approaches 0 from the left hand side. So left hand side, that means we are using 0 with a minus at the top. So limit for x approaches 0 for fx, and the value for the y, they are actually approaching 0. So this is what we mean by a one-sided limit. So we are either approaching from the right-hand side or we either approach them from the left-hand side. Okay, so just now it worked because the function is totally continuous. But this one, we have a piecewise function. That is why we need to calculate the one-sided limit. Sometimes they match, sometimes they don't match. Okay, next. Okay, so this is the right-hand limit. So this is the limit for x approaches a from the right-hand side. So we have a with a plus, so from the right-hand side then. Left hand, a from the left, a minus. So a plus, those are from the right-hand side. A minus from the left-hand side. Okay, so let's see. This is the wording part. For the sketching part, what happened? Okay. This is x, this is fx, right? Okay, so as x approaches a, let's say I choose the a over here. Okay, as x approaches a from the right-hand side, so this is the function from the right-hand side of a. This function is approaching L. The value for the fx is L. Below here, the left-hand limit is that, oops. Sabar. X, fx. Okay, let's say the a is still here and you are approaching a from the left. So this is the function approaching from the left-hand side, and this value over here is m. So that is what they mean if you want to change from the formula to the graph or the graph to the formula. So tadi daripada graph kan, fx tu kena cari y. Fx tu adalah y. Fx tu. Normally, if you learn function, right? So y and fx, they are almost similar. Cuma biasanya y ni adalah satu variable yang baru kan. But fx is a function in terms of x. Biasanya kita tulis fx tu Maksudnya kita pastikan semua variable tu adalah dalam sebutan X. Tapi kalau Y, kita boleh ada Y sama dengan Z juga. Maksudnya kita tak tentu dia punya variable tu berapa. Sebab tu biasanya kita akan tulis dia sebagai fx supaya kita pastikan semua dalam variable X sahaja. Tapi kalau ikut konsep, dia memang macam sama macam high school yang kita treat Y tu lah sebenarnya. Sebab awak tak adalah Y dalam sebutan Z pun sebenarnya. Sebab awak punya Y semua dalam sebutan X kan. Okay, next. Right, so now evaluate each of the following limit. Okay, so firstly, limit for x approaches 2 from the right hand side for x cubed minus 2x plus with 7. And then the limit for x approaches 5 from the left hand side of x minus 5 over x square minus with 25. Okay, so how to evaluate the limit? Okay, so actually they are similar with what we have done so far. We just substitute x with the value. Okay, so for example, the first one, just substitute x with 2. So every time you see the x, replace them with 2. So this is 2 cubed minus 2 times 2 plus with 7. So 8 minus 4 plus with 7. 8 minus 4 is 4. 4 plus 7. So they will become 11. Okay, and then the second one, you have the limit as x approaches 5 from the left hand side of x minus 5 over x square minus with 25. So try to substitute first. This one is quite fast, but never mind. Try to substitute first. Okay, so you will end up with 5 minus 5, which is 0. And then you will see 5 square, which is 25, minus with 25, which is also 0. So you will end up with 0 over 0. So we got stuck over here. If we have 0 over 0, then you must choose either one of these method to start with. So you must choose either to factorize them first, or you can multiply them with the conjugate. So we do see something with a square, right? So normally a common sense will be to factorize them. Okay, so x square minus with 25, you factorize them. So that is how you end up with x plus 5 and x minus 5. Like I told you before, either factorize or conjugate, you should be able to cancel out the term that will give us 0 over 0. So these are the term that will give us 0 over 0. So we will end up with the limit for x approaches 5 from the left hand side of 1 over x plus 5. Substitute x with 5. So we are going to get 1 over 10. Okay, so I think that's all for today. You have learned about the limit, the properties of limit, how to find the limit, what happened when we have 0 over 0. So we have done up until there. After this, we will continue with what happened if we have something over 0 and what happened if we have infinity over infinity. So basically for limit, we are interested with 3 different cases. Kalau tak dapat apa orang kata, tak dapat nilai tu tak apalah. But limit, sometimes when you substitute, you can get the value straight away. So this is okay. If you get the value straight away, that is okay. But what happen if you have some 0 over something? Then if you have 0 over something, this is also equal to 0. What happens if you have 0 over 0? If you have 0 over 0, then you should choose either to factorize or multiply with conjugate. What else we are interested with is that if you have something over 0, so this one, they will become infinity. So later on, I'll teach you how to check whether is it a plus or minus infinity. Another thing is that if we have infinity over infinity, what can we say if we have infinity over infinity? Should we say they are equal to 1, or should we say they are actually infinity? So these are the things that we are interested with when we want to calculate the limit. Biasanya limit ni kita banyak pakai untuk lukis reciprocal punya function. Sebab tu awak akan nampak dia, biasanya kita belajar dia dululah, lepas tu kita lukis untuk reciprocal tu. Tapi disebabkan reciprocal awak function yang mudah je, so kita boleh terus kira. Tapi biasanya kalau kita dah belajar limit ni sepatutnya kalau nak lukis yang kuasa 2 kat bawah ke kuasa 3 dekat denominator tu, semua tu tak ada masalah lah sebab dah belajar konsep limit. Okay, so now these are what we are interested with in limit. So today we have already done 0 over 0. So later on we will continue with something over 0 and then what happen if we have infinity over infinity. Okay, so that's all for today. So I'll see you guys later on untuk tutorial. So bye bye. Have a nice day everyone.